a body is in equilibrium when the sum of all the forces acting on it is 0. It means whatever the force is, the resulting force is 0. The resulting force on a body is 0. Now that both the weight and the normal reaction are cancelling each other. Here also weight and normal reaction are cancelling each other. So both are in the state of equilibrium. There are two types of equilibrium basically, I told you. One is the static and other is dynamic. If the body is at rest, like you are sitting on the chairs, the things are lying all around you. These are in the state of static equilibrium because the weight of your body is applying vertically downward. As a reaction, the surface over which you are sitting is giving an upward reaction force which is equal to your force. Upward reaction force is equal to your force. That's why you are sitting. That's why the objects are lying over here. The chairs, table, desk, or all these things are lying over here. Okay. So this is the static equilibrium. This is another dynamic equilibrium. Dynamic equilibrium. In the case of the dynamic equilibrium, what happens basically? The body is moving with uniform velocity. In either state of equilibrium, remember a very major thing, that acceleration must be 0. If the body is at rest, there is no question of acceleration. I told you that if the body is having the terminal velocity, I used the term terminal velocity. I told you the example that when the body is falling, a parachute is falling from the height and he opens the parachute. After some time, his weight and the upward air resistance become equal to each other. They are cancelling the effects of each other. So what happens basically? The body is coming with downwards with a uniform velocity. That uniform velocity is called terminal velocity, and when the body is moving with terminal velocity, it means acceleration is 0. In that case, acceleration is 0. So that is also the state of equilibrium, which is called the dynamic equilibrium. Okay.
This car is in dynamic equilibrium because it is moving at constant velocity. The forces in all directions are balanced.
And there are two conditions of equilibrium. The first condition of equilibrium, the sum of all the external forces, acting on the body is equal to 0. The sum of all the forces acting on the body must be 0. It means the forces, whatever the forces are applying on the body, they must be cancelling each other. Remember this is the first condition of equilibrium, that if the body is in equilibrium, then we must be sure about that the sum of all the forces which are acting on the body, that must be equal to 0. Okay. It means the forces might be cancelling each other. That's why their total effect, their resulting effect, the resulting effect of all the forces must be equal to 0. This is the first condition of equilibrium. Here is the pivot. At pivot, whole of the weight is acting vertically downward. As a result, the reaction of that weight is vertically upward. What is the second condition of equilibrium? The second condition of equilibrium states that the sum of clockwise moments must be equal to sum of anti-clockwise moment. Now here you can see that this ruler is balanced over it. So here the clockwise moment equal to anti-clockwise moment. So that body is in the state of rotational equilibrium. We say it rotational equilibrium basically. Okay. So this is also in the state of equilibrium. We also use the word torque, T-O-R-Q-U-E, torque. We also use the word torque for moment of force. I told you that the moment of force or turning effect of the force is also called torque. So torque, moment of force or turning effect of force. So clockwise torque is equal to anti-clockwise torque. So there are two conditions. The first condition, that the sum of all the forces acting on the body must be 0. The second condition of equilibrium is this, that the sum of clockwise and anti-clockwise torque must be equal to 0, or these torque must be equal. The anti-clockwise moment must be equal to clockwise moment. So this is the second condition of equilibrium. If the body is in equilibrium, these two conditions must be satisfied. The weight of the body and reaction. Here also, I told you that this is the rotational in the state of rotational equilibrium. Here also you can see that sum of clockwise torque is equal to sum of anti-clockwise torque. So these two conditions are satisfied here. There are three states of equilibrium. One is stable, unstable and neutral equilibrium. First of all, let us discuss the unstable equilibrium. First of all, I am going to discuss the unstable equilibrium. Here you can see that these two bodies are in a state of equilibrium, but what type of equilibrium it is? These two bodies are in the state of unstable equilibrium. These two bodies are in the state of unstable equilibrium. Look here, why it is unstable equilibrium? Because when we are giving a slight, we are applying a little force on it, it will not regain into its previous orientation. Okay? It will not gain its previous orientation. And we also discussed that the what is center of gravity? What is center of gravity? The point through which the whole weight of the object appears to act for any orientation of the object. For any orientation of the object, that point is called center of gravity. So whatever the orientation of the body, for example, I am keeping this body like this, or I am keeping this body like this. These are the different orientations of the body. I am keeping the body like this. For any orientation of the body, the center of gravity is not changing. So I was telling you that these two bodies are in a state of unstable equilibrium. Why they are unstable? Because a slight touch, due to the slight touch, it is not coming back to its original or previous orientation. At this time, its orientation is vertical orientation. Its orientation is horizontal orientation. So when I'll give a slight touch, these two bodies will not come back to their previous orientation. Okay. So if now I'm going to touch this slightly, please observe it very carefully. Now, okay. Now it is not coming back to its previous position. Okay. In the same way, if I am giving a little small, slight touch to this, it is not coming back to there. So this is the state of unstable equilibrium. If I am applying a little force, it is falling down. It is also falling down. It was unstable. So due to the slight jerk, this is also falling down because it was also in the state of unstable equilibrium. And these bodies are not coming back to its previous orientation. So this type of equilibrium is called unstable equilibrium. Now, as for the stable, the second one is the stable equilibrium. The stable equilibrium, like if I am placing this wooden piece like this, I apply the force like this. The moment I am leaving it, it is coming back to its previous orientation. So this type of equilibrium is called stable equilibrium because the body is coming back to its original orientation, its previous orientation, I mean to say. So if I am applying the force and after removing the force, the body is coming back to its previous orientation. In this way, in this state, if the body is lying, then it is called stable equilibrium. When it was in this orientation, its height from the base is definite height. So when I am lifting it, the center of gravity is also lifted. The moment I am leaving it, again the height of the center of gravity from the base comes back to its original position. Center of gravity, the height of the center of gravity remains same after removing the force. So that is why it is stable equilibrium. Okay. Now the third type of equilibrium is called neutral equilibrium. The third is neutral equilibrium. For the neutral equilibrium, you can have the example of this ball. You know that the ball has a center of mass. The ball has a center of gravity. Where is the center of gravity of this ball? At the center? At the radius? At the radius? No, yaar. In the middle, somewhere in the air of this ball. The center of gravity of this ball is lying inside the ball. Inside this ball. The center of gravity of this ball is lying inside the ball in the center. Okay? So its height from the surface over which it is lying is the radius of the ball. Is the radius of the ball. So if this ball is rolling like this, so its height, its radius is changing or not? Radius not changing. So it means its height from the base is not changing. When I am rolling it like this, I am applying the force to roll it over. So its height is not changing, neither raising, not going down. So in this way, it is called in the state of neutral equilibrium, because if you are changing the position of this ball, the center of gravity is not changing its height. So this type of equilibrium is called neutral equilibrium. You can see that this body is standing. The weight is vertically downward. As a result, the normal reaction upward, the body is at rest. Here, now please observe this ruler very carefully. This ruler is balanced. Here at the middle is the center of gravity. So here the whole weight of this body is being concentrated, because you know that this part has its own weight, this part has its own weight. If I am able to divide this body into different parts, then every part has its own weight. Listen to me very carefully. If I am able to divide this body into different parts, as many as I can do easily, so you know that each and every part, even each and every particle has its mass, and when there is mass, there will be a weight. So each and every part is acting its weight vertically downwards. Okay? So all these weights are joined together at center of gravity. So this point becomes center of gravity, where it seems that all the weight of the body is being concentrated.